Hello and welcome to the next video in my series on basic statistics. If you are new to the channel, welcome. If you are a returning viewer, great to have you back. Now when you get to the end of the video, if you like it, please give it a thumbs up, leave a comment, or share it with other people who you think might benefit from watching it. So let's go ahead and get started. So this video is the first in a series about basic descriptive statistics. And the good thing is the content is not all that difficult, but it will give you a firm foundation upon which to build as you go further into stats and study more complex topics, because understanding your data is paramount to knowing what kind of questions you can ask about your data, what kind of statistical tests you can run on that data, and of course how to interpret your findings. So this first video is about summarizing data for a categorical variable. Now this video is brought to you by the Great Courses Plus. If you are watching this video, you're here to learn something. And the great thing is that the Great Courses Plus is all about helping you learn things, and many varied things at that. So there's more information in the description below, and at the end of the video, I'll talk a bit more about how the Great Courses Plus can help you with your learning. So first, let's talk about what categorical data actually is. So categorical data uses labels, names, or other descriptors to identify exclusive categories, and that's important, exclusive categories or types of things. So here are some examples. Let's say region. So maybe a region of a country, state, or territory. So common ones are north, south, east, or west. Now you could have others like northeast, southwest, or so forth. But let's say you have a office or a factory, and you want to label where it's at. Now, in this case, it cannot be in both north and east the way these categories are set up. You'd have to create a different category called northeast. So that's what we mean by exclusive. How about a machine in a factory? So we could have machine 1, machine 2, machine 3. Or a car make. So a Ford, a Toyota, a Lamborghini, or my favorite, a Koenigsegg. Now, I'm sure you've also heard about quantitative data. So quantitative data, in comparison to categorical data, are numerical values that represent frequency, measurement, or something else like that. So let's look at our regions up above. So we have the region of north, south, east, or west, and we could have a quantitative data point for sales for those regions. So maybe $1.2 million for north, 3.5 million for south, 10.4 for east, and 8.8 million for west, for example. So the three machines above could have production units, 983, 1085, and 899. Now it's important to point out that again, those quantitative values go with exclusive categories above. Or we could have the fastest car in miles per hour. So the fastest Ford, which is the Ford GT, will go 216 miles an hour. The fastest Toyota ever made, which I believe is the Supra twin turbo, I'm a car person if you can't tell, is 156. The Lamborghini Aventador will go 217 miles an hour. And the Koenigsegg Agera R, or RS, just set a record for 286 miles per hour here in the US. So you can see that we have categories above that are exclusive, that are what we're talking about in this video. And then later we'll talk more about quantitative data, which are numerical values. So just fundamental to understand the difference between the two types of data as we move forward. So here are some fake data about smartphone users in the United States. So let's say we did a fictitious study of 100 smartphone users in the US, and we asked them, who made your primary smartphone? Because sometimes people have more than one. Let's just say your primary smartphone. And this is what we have. So we have a mix of Apple, Samsung, LG, other kind of captures everything else, and Motorola. And this is actually approximately the distribution of cell phone makes here in the US. So here is our data. Now the question for this video is, how do we make sense of this? This is just a bunch of rectangles with brands in them or makes of phones in them. So let's make some sense of it. So the first thing we could do, and it's very simple to do, is create what's called a frequency distribution. Another way of saying that is we just count them. So we go back to our data we had in the previous slide and we just count how many people had Apple phones. There were 45. HTC were 2, LG 10, Motorola 4, Samsung 28, and other mix of brands 11. Now, as we said, we had 100 observations on the previous slide. So when we add up our frequencies, it better add up to 100 or we made some type of error. So you have to check your frequencies and your totals to make sure they add up to how many observations you had. But again, this is very simple. Count it up and write the frequency over in the right-hand column. Now what we can do to visualize this is to make a frequency bar chart. Again, not all that complicated. So here along the bottom, which is our x-axis, we have the brand of phone, Apple, HTC, etc. Over here on the left, on the y-axis, we have the frequency. And then all we do is create a simple bar chart so we can visualize the distribution of phones among these brands. Now I do want to caution you here that you've probably heard of something else called a histogram, and it looks very similar to a bar chart. Now there are some differences. A histogram is for quantitative data. The charts look different. On a histogram, there is no space between the bars. So what we're doing here is a basic bar chart where we're counting up the frequency of each phone with space between the bars, and you can do that in Excel or any other stats program. Now we can also talk about another measure called the relative frequency. And again, it's not all that difficult. So the relative frequency of a class, which is sort of a part of the category, is the frequency of that occurring over all of our observations. So for example, in this case, the relative frequency of Samsung is 28 observations out of 100. So there were 28 people in our data that had a Samsung phone out of 100 people total, and therefore the relative frequency is 0.28. Now we can create a frequency distribution, which is very similar to the other chart we created. So here we have our smartphone brand, our frequency, what we did a couple slides ago, and then the relative frequency for each one. Now I will say that I made this very easy by having 100 observations, but that's not always going to be the case. Actually, that'll rarely be the case. But still, it's the frequency divided by the total number of observations, and that will give you your relative frequency. So in this case, Apple, we had 45 people have an Apple phone out of 100. 45 divided by 100 is 0.45. And you can see how that goes down the chart. Very straightforward. Now we can do the same thing for a frequency bar chart, a relative frequency bar chart. Here it looks exactly the same. Except the only difference here is that on the left-hand side on the y-axis, we have relative frequency instead of the actual frequency or the counts. But the basic idea is the same. Very straightforward, very simple. But when you have other data where the observations aren't 100, this is going to be a bit different, but you can see how it works. Pie charts. Let's talk about pie charts for a second. This is what it would look like if we did a pie chart for our data in this example. If you notice, it's very difficult to read, and pie charts should not be used. The only time you should really use a pie chart is if you have only two categories. So it's very hard to visualize proportionally in a pie chart, when you have a lot of different categories. So don't use pie charts, and definitely don't use any 3D charts unless it's absolutely necessary. So when you're in Excel or something else and you see all those cool 3D charts, don't use them, and definitely don't use a 3D pie chart. So that is my soapbox on pie charts. This video is brought to you by the Great Courses Plus, where you can get unlimited access to over 8,000 different video lectures taught by award-winning professors from the Ivy League and other top schools around the world. You can learn about anything that interests you: science, literature, and yes, statistics, like this lecture from Professor Michael Starbird called Data and Distributions, Getting the Picture, from his course, Meaning from Data, Statistics Made Clear. And right now, the Great Courses Plus is offering my viewers a free trial. So go to thegreatcoursesplus.com/Brandon Foltz to have access to the 8,000 video lecture library, or click the link in the description below. Okay, so that wraps up our first video on descriptive statistics, where we talked about how to summarize data for a categorical variable. Again, very simple, very straightforward, but it's a building block for what we're going to do going forward. So thank you very much for watching, and I will see you in our next video.